Today we are going to continue the chapter 3, system of linear equations using Thomas method. Thomas method is actually one of the LU decomposition methods where our linear system AX equal to B, we can decompose it become A equal to LU, and then we solve for L and U, where the L is actually the lower triangular matrix, only lower part, mean this is a main diagonal, and below the diagonal consists of value, upper triangular consists of 0. Okay, U is upper triangular. See, okay, from this main diagonal, and upper part consists of n value, bottom part consists of 0. A decompose become LU, so AX equal to B become LUX equal to B, and let's UX equal to Y, hence LY equal to B. So we solve vector Y by forward substitution, and then from UX equal to Y, solve vector X by backward substitution. There are 4 types of LU decomposition method. The first type is liter method. Okay. The difference is the liter, you have L here. So the diagonal of L is actually 1. In the lower triangular matrix, the diagonal is 1. Okay. Crowd is actually diagonal of Q. Crowd we have Q, so diagonal of Q is 1. Thomas, where matrix A must be 3 diagonal, then you have matrix A here. Okay, this is main diagonal. Okay, this is upper triangle, upper diagonal. This is bottom diagonal. Other entry are 0. This is 3 diagonal, and then diagonal of Q. Okay, take it as 1. Cholesky, where A must be symmetric positive finite, and U is equal to L transpose. Next class we're going to look at symmetric Cholesky method. Your syllabus only covers the Thomas and Cholesky methods. So to use Thomas method, make sure A must be 3 diagonal, or you can arrange it become, initially may not 3 diagonal, you may arrange it become 3 diagonal matrix, and then step 1, from A equal to LU, solve for L and U, and then A is actually equal to LU, so LUX equal to B, where the UX actually equal to Y, hence LY equal to B, solve for Y by forward substitution, then from UX equal to Y, solve X by backward substitution. AX equal to A is actually LU, so LUX equal to solve L and U, step 1. Step 2, UX equal to Y, so you have LY equal to B, solve Y, solve Y from LY equal to B. Step 3, you know UX equal to Y, Y obtained in step 2, then you solve for X in step 3, which is the original system, the unknown X that we are going to solve. So Thomas method, make sure A must be 3 diagonal matrix. This is general form of 3 diagonal matrix, means you have a diagonal. It means D stands for diagonal, D1, D2, Dn minus 1 up to n. So you have this is the n by n matrix. Okay, C2 is the entry below the main diagonal. Start from row 2, C2 up to Cn. E is the entry on top of diagonal. Start from row 1 to E1, E2 up to En minus 1. So total is only 3 diagonal. Example 1 of 3 by 3 system. So for A, which is 3 by 3, you notice A31 equal to A13 must be equal to 0. For 4 by 4 system, you notice this one, A13, okay, is equal to A31, but they're symmetric. 1 equal to A14 equal to A41. Equal to A24 equal to A42 equal to. So if 3 by 3, only A31, A13 is 0. Okay. 1, 2, 3, 3 diagonal. So for 4 by 4, A13, A13, A31 symmetric. A14, A41, A24, A42 must be equal to 0. So this is a 3 diagonal. To solve the system of linear equation below by Thomas method. Okay. So before we solve, make sure the matrix A. Okay, this is A is actually 3 diagonal. Because this is friendly equation where they tell you directly using Thomas method. Okay, if not, make sure if they are not mentioned by Thomas method, make sure to use Thomas method. Make sure A is 3 diagonal. A31, A130. Once matrix A is 3 diagonal, then you can solve it using Thomas method. So step 1, from A equal to L, you solve for L and U. This is A, this is the L, this is the U. Okay. So this is the product of LU. The product of LU also, make sure A31, A13 must be 0. Okay. This is 3 diagonal. And then okay, your L is actually lower triangular matrix. Okay. A31 must be 0. Okay. For U, A13 must be 0. Okay. Remember, Thomas diagonal of U is 1. So L is lower triangular. So A is ABC. If crowd, okay, this is not non-zero. If crowd method diagonal of U is 1. This entry is not 0. This entry is not 0. If solve using Doolittle method, okay, diagonal of L is 1. This is non-zero. Okay, Doolittle is only diagonal of L is 1. It's non-zero. Okay, means A, B, C, D, E, F, A, G, H, I, J, K, L. If diagonal, this is not 1. Sorry. If Doolittle here 1, so it solve this A, E, C, D, E, F, G, H, I, J. So, in the syllabus, you can look at the step. Okay. For Thomas, make sure the L or 3 by 3 system, L here, this is 0, A31 is 0, U, A13 is 0, and then L is lower triangular, so it consists value A, B, C, D, E. Okay, diagonal of U is 1, E, F, G. This one must be 0, so that when you multiply it, the row, okay, the A13, A12 must be 0. Okay, now we do the matrix, okay, product. First, do the matrix multiplication. So L is 3 by 3, U is 3 by 3. Okay, number of column in L equal to number of row in U. So these two L and U will multiply, and the product is actually 3 by 3. Okay, the result is 3 by 3 dimensions. And then for metric multiplication, it's actually row times column. First row times first column, you get this result. A times 1. So 0 times 0, 0 times 0. So it's E. Okay, and then we move to, next we move to second column. So you have what? A times F. Because the other two entry multiplied by 0. So the result is AF. Okay, next, we move to third column. A times 0. 0 times G, 0 times 1. So the product is 0. Then I will move to second row. And then the column 3. So that is second row, third column. B times 0. C times G, 0 times 1. So second row, third column, result is CG. I'll move to second column. Second row, second column, we have B times F plus C times 1. So BF plus C. We move to first column. B times 1, which is B. Now I move to the third row. So we got 0 times 1 is 0, B times 0 is 0, E times 0 is 0. This is 0. Move to second column. Zero times F, 0, D times 1, E times 0. So it's move to third column. 0 times 0, D plus G, E plus 1. So DG plus E. So this is the product of LU. Okay, the product of LU here. Okay, and then we equal A. We equal the LU equal to A. So we have 3 by 3 system. So I draw 3 by 3 tables here. So we compare first row, first column. So A equal to 1. Where is A equal to 1? So on first row, second column, AF equal. So A is 1, so F will be 2. Or 2 divided 1. This is 2. We go to B. Second row, first column, B equal 6. B equals 6. And then here, second row, second column, BF plus C equal 6. So plug in B, plug in F. So 6 times 2 plus C equal 6. So C is 6 minus 12 equal to negative 6. Okay, and then here, D equal negative 3. Cell CG equal negative 8. CG equal negative 8. Plug in G. So you want to find the G. Plug in C here. Negative 6G equal negative 8. So G is 4 over 3. Lastly, the last value, DG plus E equal what here? DG plus E equal 1. Okay. So plug in D here, G here. So mean negative 3 and 4 over 3 plus E equal 1. E is actually 1 plus 4, which is equal 5. So you put up, okay, the value. The L is actually 1, 6, 0. A, B, C is here, negative 6, D is negative 3, E is here, 5, 6, 0, 0, 0. Okay, actually here represents your L. 1, 6, 0, negative 6, negative 3, 5. This is L. Okay, this part represents your U. U, okay, U here, U is upper triangular, so you have 0, 1, 0, 0. F is here, 2, this is 1, this is 0, this is 1. This is a G, 4 over 3, this is 2. This is a U, U here. F, G. So step 1, make sure to obtain L and U correctly. Okay, to make sure that you calculate correctly, suggest you to do the metric multiplication of L and U quickly using some calculator. Double check L multiply U, get back to the A. This you go to the matrix mode. It defines the matrix what A is 3. Key in L into A in your calculator. 1, 0, 0, 6, negative 6, 0, 0, negative 3, 5. 6, 0, 0, negative 6, negative 3, 0, 0, 5 is L. I key in as a matrix A in the calculator. It's the option. Number 1, define matrix. Now key in the U as a E. E, choose option 2. 3 rows, 3 columns. This model you can up to 4 by 4. 1, 2, 0, 0, 1, 4, 5, 3. See, now I'm going to multiply LU as AB in the calculator. So options, matrix A is number 3. So multiply options. Matrix B is number 4. So I get 160. I leave the original A. Second column, 2, 6, negative 3. Third column, 0, negative 8, and negative 8 and 1. So, okay, with this you can confirm that you calculate correctly for your L and U. This is your step 2. Step 3 now. From Ly equal to B, solve for Y by forward substitution. Forward substitutions here. Means you start from first row to third row. So this is actually Y1, here Y2, Y3. So Y1 equal to 9. 1Y1 plus 0Y2 plus 0Y3 equal to 9, so Y1 equal to. And then 6Y1 minus 6Y2 equal to 1. Okay, calculate for Y2. So your Y2 will be 6Y1 minus 1 by 6. Where the Y1 is 9 minus 1 by 6. Then you can calculate it. Lastly, the third equation is negative 3y2 plus 5y3 equal 0. Calculate for y3. So mean y3 equal to 3y2, y2 which is 3 over 6 divided by 3 by 3. 3 350. Okay, this is using forward substitution manually. Forward means start from equation 1. Backward start from the last equation. This is manually, or you may go to the equation mode. Key in the system Ly equal to B into this equation, and up to 4 unknown. Here we got 3 unknown. Key in the system Ly equal to B. 1, 0, 0, 9, 6, negative 6, 0, 1, 2, negative 3, 5, 9, 3 over 6, 5.3. Okay, later on, okay, from the third step, from ux equal to y that we obtain, this is in step 2. Okay, u is here, this is the u. Okay, so u x equal to y. So you may key in, solve it manually by backward substitution, or you can key in into calculator in equation mode to obtain the vector x quickly. We want to solve by backward substitution means from the last equation. So x3 equal to 5.3. Second equation, between x1, x2, x. Second equation, 1 x2 plus 4 over 3 x3 equal to this value, 3 over 6. So you want to find x2, 3 over 6 minus 4 over 3 x3, which is okay, calculate it there. And then from the first equation, we have x1 plus 2x2 equal to 9. So x1 will be 9 minus 2. Okay, x2, what is this then? 3 divide 6 minus 4 divide 3 multiply 3 by 10. So this is 3 over 30. Come for my 6, 6, 7. 7, 6, 6, 7. And the x1 is 9 minus 2 times answer, which is 2. 9 minus 2 times 5 point time 3 by 30. Get the x2. Then this one is 5.4667. The x1 5.4667. x3 5.3. x2 1.7667. x1 is 5.4667. Okay, or you can key in the system ux equal to y into your equation modes. Equation modes. As it becomes in this case, equation modes, simultaneous equation, 3 unknowns. So key in the system ux equal to y. 1, 2, 0, 9, 0, 1, 4 divide 3, 53 divide 6, 0, 0, 1, 5.3. So x 5.4667, y which is x2 1.7667, okay, z is tallied with the x3, okay, which is 5.3. Okay, and you can always double check with the original system and key in the original system in equation modes, and the answer should be tallied with the step 3. 1, 2, 0, 9, 6, 6, negative 8, 1, 0, negative 3, 1, 0. Same. This is, I keyed into original system. So means the step 2, you can skip the forward substitution, but using equation mode to obtain the y directly. Step 3 also, you can skip the backward substitution by keying into the system ux equal to y to obtain the x. Of course, the x that obtained must be tallied back with the original system. And then once you, as what just now, when you obtain the L and U, can use matrix multiplication to always confirm that the L and U that you obtained are correct by the product of LU must equal back to the A. Using the matrix multiplication mode in your calculator. And before you use a Thomas method, make sure the system is actually tridiagonal. Okay, sometimes if it is not tridiagonal, you can swap it. Okay, you can swap it become tridiagonal. Question 2a, this is not tridiagonal initially. However, if you make this one, make this become first row, then this will be entry A13, A13 becomes 0, this H1 becomes 0, then become tridiagonal by swapping row 1 and 2. Okay, so in this case, thank you for your attention.